Hello, in this lesson we're going to study transformations of functions. This is a powerful idea in mathematics because instead of graphing functions from scratch, we can take a familiar graph, what we call a parent function, and transform it. We'll learn how to shift graphs, reflect them, and change their shape using stretching and compressing. As we go through this lesson, focus on how the equation changes the graph. By the end of this lesson, you should be able to use vertical and horizontal shifts to sketch graphs, use reflections to sketch graphs, apply non-rigid transformations like stretching and shrinking. The goal is to look at a function and quickly understand what its graph will look like. Let's begin with shifting graphs. A transformation is any change made to a graph. Shifts are one of the simplest transformations. They move a graph without changing its shape. We use the form f of x minus h plus k, where h controls the horizontal movement and k controls the vertical movement. So we're taking a known graph and sliding it in different directions. Let's look at how these shifts work. If we add a number outside the function, f of x plus c, this moves the graph up. F of x minus c moves the graph down. If we change inside the function, f of x minus c, this moves the graph to the right, and f of x plus c, this moves the graph to the left. This is very important. Horizontal shifts go in the opposite direction of the sign. Let's look at this example. We have g of x is equal to x cubed minus 1. This is going to move the graph down 1 unit. The shape stays exactly the same. We are simply just shifting it down. Now let's look at a function with both horizontal and vertical shifts. H of x is equal to x plus 2 cubed plus 1. Breaking it down, the plus 1 is outside, so this is going to shift the graph up. X plus 2 is inside. This is going to shift the graph left 2. Again, remember, horizontal shifts go in the opposite direction. So this graph moves up and to the left. Now let's go the other direction, starting from a graph and writing the equation. We recognize the shape as a parabola. So the parent function is f of x is equal to x squared. We can see the graph has been shifted up 4 units. So the equation now becomes g of x is equal to x squared plus 4. The key idea here is to identify the parent function first and then apply the transformation. Now let's look at reflections. A reflection flips a graph across an axis. If we reflect across the x-axis, h of x is equal to negative f of x. This flips the graph upside down. If we reflect across the y-axis, h of x is equal to f of negative x. This flips the graph left to right. So remember, negative outside, flip, this is a vertical flip. Negative inside, this is a horizontal flip. Now let's combine transformations. We start with f of x is equal to x squared. Then reflect across the x-axis, this would be equal to negative x squared. We shift it up 2 units, so the final function is g of x is negative x squared plus 2. Always apply transformations step by step. So far, everything we've done, shifts and reflections, are called rigid transformations. This means the shape of the graph does not change. Now we move to non-rigid transformations, where the shape does change. These include vertical stretching and shrinking, and horizontal stretching and shrinking. For vertical transformations, we multiply outside the function. G of x is equal to c of f of x. If c is bigger than 1, the graph stretches vertically. It becomes steeper. If c is between 0 and 1, the graph shrinks vertically. It becomes flatter. In these examples, we see that 4x squared is a vertical stretch, and 1/4 x squared is a vertical shrink. Outside changes affect vertical movement. Now let's look at horizontal transformations. We multiply inside the function. G of x is equal to f of cx. This is one of the most important ideas in this lesson. When the number is inside the function, the effect is the opposite of what you expect. Let's look at this example. G of x equals 2x squared plus 3. Even though 2 is bigger than 1, the graph becomes narrower. This is called a horizontal shrink. Now let's look at h of x is equal to 1/2 x squared plus 3. Here the number is between 0 and 1, and instead of shrinking, the graph becomes wider. This is a horizontal stretch. The key takeaway is that when the number is inside, greater than 1, think shrink. Between 0 and 1, think stretch. Final rule to remember, outside the function is a vertical change, inside the function is a horizontal change, and they behave opposite. To summarize, transformations allow us to take a known graph and change its position or shape. We learned shifts move graphs, reflections flip graphs, stretching and shrinking change the size, and most importantly, the position of the number inside or outside tells us what type of transformation is happening. Once you understand these patterns, graphing becomes much faster and more intuitive.